In the name of God, welcome to another session to solve another problem. In this session, I want to solve another problem in heat transfer in thermal conductivity from one dimension issues, which is about some wall which is construction and the material is from stainless steel. But first, as always, let me introduce the reference, which is heat transfer, 10th edition of heat transfer from Mr. J.P. Holman. Okay. In problem number 14 in chapter 2, a wall is constructed of a section of stainless steel with K equals 16 watt per meter per degree Celsius with 4 millimeter thick with identical layers of plastic on the both sides of the steel. Okay, the overall heat transfer coefficient, considering convection on both sides of the plastic, is 120 watt per meter square degree Celsius. And if the, let me change the color, if the overall temperature difference across the arrangement is 60 degrees Celsius, calculate the temperature difference across the stainless steel. Okay, let's get started and solve this problem and get to the whiteboard and do it. Okay, first, as always, let me draw the picture of the problem. We have a steel, stainless steel here with thick of 4 millimeter, and both sides of that we have 2 layers of plastic, and the thickness of these two is not important because we don't need it to solve our problem, because we have some other parameters. For example, here we have convection. Okay, imagine we have some convection in here. Okay, as the problem said, okay, K of steel is 16, okay, and H of here will be 120. Okay, sorry, U is 120 overall. U overall. It means from center line to around someplace around here, T infinity. Okay, and K for steel is 16 watts per meter degree Celsius, and the unit of this would be meter square degree Celsius. Okay, and delta P, delta T will be overall 60 degrees Celsius. Okay, but other important parameter, just this. Okay, I wanna write the formula for all of them. Okay, we can write Q equals U as overall heat transfer coefficient multiplied by A, which is the area to transferring the heat between steel to plastic and plastic to convection to the fluid, and we assume all of the A are equal to each other and A equals 1 meter square, because the problem didn't say to us the value of area. Multiply by delta T overall, which we have it. This is 60, yeah. Okay, I can write it, this formula, as this one, delta T overall divided by R overall, which is overall resistance. Okay, overall resistance, all the resistance from the center line to convection, okay, will be like that. Okay, but I have to write, then I can write R overall equals 1 over U because of this formula. Okay, then I know U is 120, then R will be 0083. Okay, and okay, first I should mention that the problem wants temperature difference across the stainless steel from center line to the wall. It wants delta T here. Okay, delta T as stainless steel. This is the question of the problem. I know that overall heat transfer and overall resistance is something like that. Delta X1 divided by K1, okay, plus delta X2 divided by K2, which this is for steel, this is for plastic, okay, plus 1 over HA, which is for our convection. Okay, but I know the value of R overall. I have to find R for steel because I need to use this formula. I have to write the equation because I know the Q which go to the wall from steel is that Q. Okay, I know the value of that, which is delta T over R. Okay, I have the R and T, delta T, then I can't write it, but I want to write it for steel too. Okay, delta T steel divided by R still. Okay, because we can write K A delta T over delta X, and K A over delta X will be 1 over R for steel. Okay, and this is, if I put it 1 here and 1 here, this would be like something like that. Okay, this is 1 over R, that would be R. I can say R overall is R for steel plus R for plastic plus R for fluid. Okay, that would be something like that. Then R for S would be delta X1 over K1 A. Okay, which delta x, I have delta x 4 millimeter divided by K, which is 16, okay, for steel, and it will be R for steel will be 0.00025. Okay, I have this one, but I know this Q delta T for S R S S equals these delta T, okay, because these two Q are the same. Delta T overall divided by R overall, okay. I have delta T, I have R overall, I have it here because I calculated here from here, R overall from here, which one? Here, this one, R overall, and delta T I have it because this is R, it would be 1, this is 1, it would be 2, this is 2, it would be 3, this is 3, okay. I just want these temperature, okay. Then it will be delta T for steel, R for steel, multiplied by delta T overall divided by R overall. I have all of these parameters. The answer, when I put all of these three parameters to this formula, delta T for SS would be 0.58 degrees Celsius. This is the answer of the problem. Okay, this is delta T overall. Okay, thank you. This was answer of this question. Thanks for paying attention to this session. It was so great. It is so perfect. I hope you enjoyed that. So take care of yourself. Thank you. Bye bye.